Welcome, Tiny Hands, Big Dreams, here in our homestead in southern Ecuador. So on our $3,000 house project, we had an interesting thing happen. The child asked me a question. This is going to be a bit of a technical video into a natural house build. Not a lot of natural house builds get into things like that. They sort of just, look, it's all done. It's great. How'd you do it? He goes, will the roof blow off? Well, that's an excellent question, child. I don't think so. I can't say that for sure. Okay, all right. So, what we decided to do is we decided to have a learning moment and put numbers to it and try to figure out if our seat of the pants build will withstand a really strong wind that occasionally might happen here in a weird weather situation. And so we started to try to figure out, how do you do that? Well, it's a natural house build, like there's no engineer. So we simply broke it down into piece by piece, and I want to sort of showcase we're using some unconventional methods to put the thing together. This is a $3,000 house. It has to be incredibly secure and stable. It can't cost a lot of money. So we start with posties. We cut these down in the process of clearing a bit of land. We barked them. We've run the torch across them to give them a little bit of a burn for weather resistance. We have treated the bottom with the motor oil old gas combo. This keeps the bugs out, it keeps the rot off. The only problems we've had with posts around here is where they touch dirt and they rot in our wet environment, and the bugs will get in from the bottom. So this solves that. Cost, near zero. Cost of the posties, just the time to cut them down and strip them. We put them in cement. We were going to just pound them into the earth, and that might have worked. Might have. We were on the fence about it. We decided to dig small holes and just put a little bit of cement in there as a super barrier against bugs. And that was sort of it. Otherwise, we could have just, as we've done some other ones, just pounded the dirt down in as a rammed earth, and they're very solid. We didn't want these to rot. Okay. We've done a few things odd. Now, these holes are vertical. It is very difficult to pull a cement plug out of a hole. Okay. But at the bottom of the holes, let me go to portable classroom. Sometimes things are better with a picture. Bueno. Posties are like this. The hole is a little bigger, and then bells at the bottoms. This little bell at the bottom of cement creates a wedge on the sides, making it much harder to pull out. So we don't know what the pull-out strength is of that, but we're guessing it's well over 1,000 pounds. They're really in there to pull that clay up at that kind of angle. Okay, 1,000 pounds, great. How much will the wood take? Way more than we could ever imagine. These are very solid posts. As we go higher, let me come down here again. I got my postie in the cement with this little mushroom. I have cut saddles into the top, and the beams sit in the saddles. Now that holds the beam from coming down, from going sideways like that, no problems. I then went and decided we're going to tie them on. So we have set nails into the posts and run wire over the top. Let me get you a close-up of what we've done, because I've also put little slots in the top of the post to stop lateral movement. So I've now captured that beam to the post, both left, right, up, down, center. We're looking at seismic. But it also works for wind. Okay. So that's a good connection there. We start to have to then find out, so we spent some time on the internet. How much will that nail hold? It's a good question. What is the of these particular nails? we kind of got to about 200 pounds for these particular nails. They'll easily hold that. The wire is right up against the base of the nail. That's pretty solid. All right, there's 2 nails. That's 400 pounds. The wire that's wrapped around it, well, we're like, again, the wire is probably good for about 200 pounds. I could hang on it and it doesn't break. And I double it, so we're at way more than that. If there's 8 pieces of wire, we're at 1,600 pounds of wire. So the wire is not the weak link. And then we continue to build up. So now we're going to lay a rafter across here. And we're like, well, what about the rafters? Okay, so the rafters could blow off. Well, let's figure out. Well, now we have a lot of force. We're aiming for 1,000 pounds or more on the whole structure. But how much is really going to be on it? So then we back up and we're like, well, let's look at wind loading. Now we have overhangs that are going to be about 3 feet from the walls because we wanted rain protection. I don't want my posts to get wet. I want the house site to stay dry. So we have big overhangs. I really like big overhangs. At 3 feet, I can't find a solid number, but most engineers in the forum seem to say use the same as a flat wall. All right, we calculate it, and we're like, let's just pick a number. Let's pick 80 miles an hour. It's more than double we've ever seen here on a gust. The neighbors lose their roofs when it hits 30 or 40. They're just not well attached. Let's double it. Let's go 80. So at 80 miles an hour, I have to hit about 100 pounds of force per square meter. Okay, so then we look at, well, all the posts are a little different. As you can see, the spacings are not the same. So then we had to figure how much roof sits on each post. The ones along the front, there's a lot of posts and not a ton of roof. So those are no problem. There's one though that is a beauty decorative post off the corner of the kitchen that sits sort of way out there, and that has the most roof. So when we looked at that, we realized that that has more than 10, maybe 11 meters of roof on it. Now that's our weak link. So we had to work from the roof down. If the roof is going to take an actual, 1,100 pounds of load, then our rafters and our battens have to be able to transfer that load down. So the battens, we decided each get a double screw and a wrap of wire. The rafters get, I think it's about 6 wraps of wire. Keep those to the beam. Wire is really cheap. It's $1 a pound here for galvanized wire. We tend to use it in place of other things. There's no screws in this house. They're not locally available, and the ones that are just drywall screws. They're not good. So we work it down. We get it, the 1,000 pounds, great. We look at all the battens, which are going to be actual cut dimensional wood, double screws and a wrap, and then it concentrates right at the top of the beam there. And that's where we realized the weak link actually comes down to the nails that hold the wire to the beam. That's not a problem. We can add some more. So we decided that corner one has to be 6 nails, 200 pounds apiece. That's 1,200 pounds. That equals enough load to hold into the highest possible wind loading. And then we realized some of the other, the edges and the corners, we're going to double up just for safety. What's it cost us? It cost us a handful of nails and a pound or 2 of wire. We're at like $3 to be able to rate the entire house at an 80 mile an hour sustained wind. Maybe more, but that's like the best we could figure. This was all on the question of a child. Will the roof blow off? Not a lot of natural houses get into the engineering, and I look at them, and while they're very beautiful, they simply, a lot of the roofs just sort of sit by their own weight. They use heavy timbers, they use things, or, the occasional nail. Nails loosen over time, they pull out. And that's why I went with the wire it down arrangement. It will also take a fairly strong earthquake. And while I don't have like proper seismic studies on this or any sort of computer modeling, it's really more of what I think it will take. but we think it'll actually be one of the strongest houses we've seen. So that is our tiny technical discussion of will the roof blow off? I don't think so. I think it'll be great. I think this house will be here for a long time. I don't think the bugs will get to it. I don't think the mold will get to it. I don't think the water will get in. And it's these kind of little interesting tidbits that come up that when we look at interesting homes that people have built, they sort of neglect and fail on, and they, they're good on the art side and they have a lot of passion about it, but you've also got to make sure that she's going to be there and it's going to be solid for you. So that's about it. Thanks for watching. Hope to see you for the next one.